Hello, Tom again from everystepcalculus.com, everystepphysics.com. Here's a problem that was in a test. How do you integrate e to the x times cosine of 2x by integration by parts? Okay, so let's do this insane little puzzle. I'm already at integration by parts, but you notice my menu here has all these things. There's about 100 menu items in here, so when you're asked to do a problem like, I don't know, the quotient rule or whatever, you go to that in my menu and then it'll show you how to do that step by step. We're going to go integration by parts because all these here, when you're integrating, is all integration by parts, okay? There's a few that are U substitution, which I have in U substitution too, but generally the test will ask you to, just like this, integration by parts, you know. These functions are just cornball problems, like Sudoku or like maybe a crossword puzzle, and you're asked to remember all this stuff, you know, the integration of e to the x, the integration of cosine of 2x, and you know, if you study it like I do, then you can kind of recall it, but if you're got other classes, you're not going to remember this stuff very easily, okay? Very difficult. So integration by parts, let's do it. Integration by parts, and we're going to enter this function into my program, okay? So we're going to press alpha first, and then of course the function is this yellow key, and the x, which is e to the x, and then we're going to close off the parentheses, times second z here is cosine of something, so we're going to have 2 times x, close off that parentheses, press enter and see if it matches. Here's the e to the x cosine of 2x. Here we go. Here e to the x times cosine, okay, dx. So we're cool. Say it's okay. We could have changed it if we didn't want to, if we wanted to, if we made a mistake. So we're going to integrate this, okay? So we're going to use integration by parts. dv is equal to the e to the x, and v is equal to the integral of e to the x dx, okay? And so this is the derivative of v, okay, but we're working it backwards, and so the integration of e to the x is e to the x plus c, and then we have u is equal to cosine of 2x, and du is equal to the minus sine of 2x, okay? Now notice how difficult that is for you to remember. Might be easy to remember right now, but not when you get to a test, okay? And here's the formula, v times u minus the integral of v times du. So we're going to add what we've just found, e to the x times cosine of 2x, which is u, and here's v, and then integral times v, here's v, times the du, and du was minus 2 times sine of 2x dx, okay? Notice the minus sign here, okay? Notice the minus sign on the 2, all right? So the next one, I bring them both out. Minus sign, that equals a plus. And we put it together like this, all right? Now we have to do a second integration by parts because you can only integrate when there's a plus sign between the terms. You cannot integrate when there's a minus sign or a division sign or a times sign between the terms, okay? So we're going to do e to the x times here 2 times sine of 2x. Now notice we took the minus signs out. So we have du again is equal to e to the x, v, or dv, I'm sorry, v is equal to the integral again, and we come up with e to the x plus c. U is equal to 2 times sine of 2x, du is equal to 4 times cosine of dx. Now when you buy my programs and you do this on a test, why would you ever learn this stuff? It's nonsense. You'll never use it. Even if you work at NASA, you'll never use it. I'll guarantee the space shuttle never used one term of calculus in any of the calculations, you know. And you can go to my Facebook page and I'll tell you why that is. And I'm 75 years old now, and I started this stuff when I was 50 years old, going to college at San Diego State. So they made me buy this calculator, the one before this one, so I found out I could program it. So I programmed calculus in whatever class I was in. And I can still do those classes today because I have the calculators in and the programs into my computer. Here's the formula again. Okay, e to the x times 2 times sine of e dx. Now notice the integral of sine of 2x is cosine of 2 times cosine of 2x, and that's 2 times 2 is 4, right? Here we have the minus sign again. So this, of course, is the original function, is equal to e, we start to put this together, okay, plus this and minus 4 times this. Okay, give you a chance to look it over. We're going to add the integral to the left side. That's one of the tricks of this thing. Took about 2 weeks for me to figure that out. So we have the integral on the left side here, and we're going to add the one on the right side right here, which is 4 times e to the, notice these are exactly the same, e to the x times cosine of 2x here. Okay, so you add them together, it becomes 5. Isn't that cute? Here's 5, and that equals the right side, which is e to the x cosine of 2x, and e to the x times 2 times sine of 2x. Okay, so here's your answer. E to the x times cosine of 2x divided by 5, because we took the left side and through the miracle of algebra, divided the right side, divided both sides by 5, you know, so then we get plus e to the x times 2 times sine of 2x divided by 5 plus c. Pretty neat, huh? EveryStepCalculus.com. Go to my site, buy my programs. Why waste time studying this crap? $40, best $40 you'll ever spend, plus you have it for all your kids in your calculator for when they get calculus, or your partners, if they take business or anything, they always come up with calculus. Worthless calculus, but still they make you take it to pass your class and get your degree. So anyways, follow me along on Facebook. I'll tell you what calculus is really about. So anyways, good luck in your classes, and have a good one.